Hey everybody, Mr. Reeves back with you. And today we're going to be talking about rate of change and slope and unit rate. So we're going to take some of the stuff we've been talking about and try to bring it into a new concept of slope. So remember, a rate was a special type of ratio where the units of measurement were different, right? So we talked about things like miles per hour and feet per second and dollars per ounce and such things. And a unit rate was where that second quantity of the ratio was 1. So if we went 30 miles in 6 days, we would say as a unit rate we went 5 miles in 1 day. Okay? All right, so a rate of change is a little bit different with a rate. We're going to be comparing the change between what the textbook calls dependent and independent variables. All right, so that can be real confusing, but let's just make it as simple as we possibly can. Dependent means you are depending or dependent on something else. Independent means you can stand alone. So sometimes it's just easiest to see through an example here. They have a table of lawns mown and amount earned. So our first variable, if we call the number of lawns x and we call the amount earned y, this first one would be our independent variable. All right, Eve can mow as many or as few lawns as she wants to. What depends on the number of lawns that she mows is the amount she earns. The more lawns she mows, the more money she earns, right? So the amount earned depends on the number of lawns. So we say the variable x is independent, representing the number of lawns, and the variable y is dependent, representing the amount earned. All right? So the rate of change is going to be the amount of change in the dependent variable. So these ones are changing going across like this, right? Compared to the amount of change in the independent variable. All right, so we're going to take a look at those as ratios. So here we go. 15 to 45, that is a change of plus 30. 45 to 90, that is a change of plus 45. And 90 to 120, that is a change of 30. Would you agree? All right, so now let's take a look here. From day 1 to day 2, she went up by 2 lawns. So 2 lawns gave a change of $30, right? 3 lawns gave a change of $45. And again, here we had 2 lawns giving once again a change of $30. Okay? All right, now we're going to see whether it's constant or variable. Now, if you look at these changes, if you write them as ratios, we get 30 over 2, we get 45 over 3, and then we get back to 30 over 2. The question is, are they equivalent? Well, remember, equivalent ratios simplify down to the same value. We get 15 over 1, we get 15 over 1, and of course we get 15 over 1 again, right? We get the same value. All right, and so because the change in the independent variable, or often we say the change in y over the change in x, is the same, that is a constant rate of change. And that constant rate of change we're going to refer to as the slope. By the way, this happens to be a proportional relationship, correct? If you look at each of these and you simplify them, you're going to get the same result each time, right? So not only is the rate of change 15, but our constant of proportionality, if I take any of the y's over the x's, I get 15 over 1. So k in this case, which is our constant of proportionality, is also our rate of change. So we're measuring two different things, but we get the same value. The change in y over the change in x, by the way, you will often see it written like this, delta y, delta x. So our change in y over our change in x actually turns out to equal simply any of our y's over our x. That will be true if it is a proportional relationship. Okay? Alrighty, let's take a look at the next page here. And what we're going to do is we're going to relate this to a graph. Okay, so when we take a look at this graph, remember there was 3 ways to represent a proportional relationship. There was a table, there was a graph, and there was an equation. And you remember when you're looking at the graph and you want to determine if it is a proportional relationship, you look at 2 things. Does it pass through 0, 0? And is it a straight line? And in this case, it is, right? It is a straight line that passes through 0, 0, or the origin, as we say, 0, comma 0, passes through 0, 0. All right, and now that we know the terminology, a straight line, I'm going to let you know, means that you have a constant rate of change. So when you see a straight line, you have a constant rate of change. When you see a straight line that passes through the origin or passes through the point 0, 0, that means it is a proportional relationship, right? So again, if we take a look at each of these, the change in the y plus 15 plus 15 plus 15, and the change in the x plus 1 plus 1 plus 1, right? So our change in y, our delta y over our delta x, that is our rate of change, in this case is 15 over 1. We would say that that is the slope of the line, all right? And we're going to call the slope of the line is going to be used the letter m. But remember what we just said previously. Because this is a proportional relationship, if I simply look at y over x, what do I get? I get 15 over 1. I get 30 over 2. I get 45 over 3. And I get 60 over 4. Those also equal 15 over 1. So this is what we're going to end up with, okay? We're going to have y over x equals k. We already knew that. And that is going to equal our change in y over our change in x, which we're going to call m. Okay, and remember k was our constant of proportionality, and m is going to be our slope, which is our rate of change. Okay, so I know this is a little confusing. So again, the rate of change is this one right here. It's the difference between the y's. Let me color code it here. And the difference between the x's, okay? That's our rate of change. Where our y over k, let me use 2 different colors, okay? Our y over our k is simply take any of these y values, like this one, over any of these x values, okay? So y over x, okay? Y over x. So you will notice in a proportional relationship, the rate of change is equivalent to y over x. The slope is equivalent to the constant of proportionality. It's kind of cool. It's kind of cool that way. All right, here on page 511 is where they're defining slope. All right, slope again is the rate in change. All right, this is what I'm calling my delta y on the top, and on the bottom is delta x. We often refer to that top part as the change in y, and the bottom part we refer to as the change in x. And if you want to know the change between any 2 things, what can you do? You can find the difference, right? This is the difference in y over the difference in x, right? If you took your height measurement 2 different years and you said, how much did my height change? You wouldn't add, you wouldn't multiply, you wouldn't divide, you would subtract. All right, so slope, change in y over change in x. Slope is the rate of change, is the difference between 2 y values. By the way, let me go back here to this one. We were doing 1 to the next, right? What you can know about slope, again, another exciting thing is, what if I went from the first one to the last one? And I said, well, what's the difference there? If I did 60 minus 15. What do I get? I get 45. If I did that same difference there, if I did, it's hard to see. There's lots of writing over here. 4 minus 1, what do I get? I get 3. So 45 over 3 is 15. So the great thing about finding slope, finding that rate of change, you don't have to pick 2 points in a row. You can pick any 2 points on the line. I did back-to-back points, and then I did the first and the last. I could do the first and the third. I could do the second and the fourth. Any 2 points on that line, that rate of change will be the same. All right, so when it says tell whether the rates of change are constant or variable, real quick, 3 to 12, 12 to 27, 27 to 75. Here we go. I'm going to call this X. I'm going to call this Y. Right? Well, 3 to 12 is plus 9. 12 to 27 is plus 15. 27 to 75. Oh, my goodness. Well, 25 to 75 would be 50 minus 2. That's going to be what? 48. And then here we have plus 3. We have plus 5. And 10 to 25, that would be plus 15. So this one is plus 16. Okay? So my change in y over my change in x. Remember, that rate of change is going to be the change in y over the change in x. So I would do 3 over 9 for the first one, right? And that simplifies to 1/3. Then I would do 5 over 15, and that simplifies to 1/3. And then the last one, I'm going to do 16 over 48, and surprise, surprise, that simplifies to 1/3. Therefore, this is a constant. And by the way, if it is a proportional relationship, I will get that same result by dividing simply y over x. If I do that, 1 over 3, 1 over 3, 1 over 3, and 1 over 3. So not only is our slope 1 over 3, but our constant of proportionality is also 1 over 3. All right. If we take a look at this one, similar, right? 6 divided by 2. This time is 3 over 1, 3 over 1. This one, however, is not 3 over 1. Do you see that? 25 over 7. So that means we should also not have a constant slope. So this is plus 6. This is plus what? 13. This is plus 2. This is plus 5. So if we did, again, this is our x and this is our y. If we do change in y over change in x, the first one is 6 over 2, which is 3. The next one is 13 over 5, which is not 3. So this one would be variable. And if we were to plot these points, they would not make a straight line. All right, they would not make a straight line. All right, what if you're given a graph and you're asked to find the slope? All right, again, you can pick any 2 points on the line. So if I pick that point and I pick that point, right? And if I go this way, I'm going to go down, and then I'm going to go over, right? So this point right here, by the way, is -1, -2. So this is -2, 1, 2, 3, 4. And this point right here is a 1, and then -2, right? So if I looked at my, again, what am I looking for? My change in y over my change in x, going from that point to that point. Well, from 4 to -2, I went down 6, right? So my change in y is -6, or if you wanted to subtract 4 minus a -2, all right, that actually is going to give us a positive 6, but we went in a negative direction. All right, if we do this next one, from there to there is over 1, 2, 3. And so my rate of change, or my slope, is -2. Now, if I did the subtraction one, since I did 4 minus -2, if I do -2 minus 1, in that case, I would get -3, right? So I'd get the same answer. I like to use the direction way, all right, but you can also use the subtracting way. Either way, whether you subtract to find the change or whether you look on the graph to find the change, you get the same result, okay? Just so you know, the slopes that go down from left to right are going to be negative. This one right here, do you see how this goes up from left to right? This is going to be positive. Again, pick any 2 points that are on the line. So I'm going to pick that point, and I'm going to pick that point. This time, if I'm going this direction, okay, I'm going to go up and I'm going to go over. So if we're just using the graph, it's 1, 2, 3, 4, 5, 6 going up in a positive direction, and 1, 2, 3, 4 going to the right. So my slope for this one, again, my change in y over my change in x would be 6 over 4, which would simplify to 3 over 2. If I did the subtraction method, well, then I need to take a look at what these points are. So this point is negative 2, 1, 2, 3, negative 3. This point right here is 1, 2, and then 1, 2, 3. Okay, so if I do my change in y, all right, since I was going from this point to this point, I'm going to do negative 3 minus, that was a positive 3. My apologies for my sloppy writing. All right, and that actually turns out to be a negative 6 when I subtract. But also then when I do the x values, if I do negative 2 minus 2, that turns out to be, sorry, not negative 2 minus negative 2, negative 2 minus positive 2. That turns out to be a negative 4. And I get a positive 6 over 4, which simplifies to a positive 3 over 2. Okay, so whether you subtract to find the change or whether you just count it off on the graph to find the change, you will get the same result. Remember, when you're counting off on the graph, going up is positive, going down is negative, okay? Going to the right is positive, and going to the left is negative. And slope is either positive or negative, so it is very important that you pay attention. If I put a positive 2 for this answer, it would be wrong. If I put a negative 3/2 for this answer, it would be wrong. So pay close attention to those signs. I like to just look at the picture. If I have a picture, and immediately say that's a negative slope because it's going down from left to right. That's a positive slope. It's going up from left to right. Okay? So that's how you work with slope. I think on this video, I'm not going to go ahead and talk about unit rate as slope. We'll save that for the next video. All right, thanks everybody.